So let's go ahead and talk about the concept of a dissolved buffer. So just like variable buffer built upon the buffer concept by allowing us to have multiple different distances for different features, what a dissolved buffer allows us to do is a dissolved buffer allows us to merge overlapping buffers. A dissolved buffer will merge buffers that overlap when creating the output. So what I mean when I say that, right, is everything that we've done so far, right, if we had a buffer like that, and then we had a buffer like that, right, we kept it like that. We had two separate circles. So we had two separate buffers, right, with two separate records in the attribute table. Right? Because even though they overlapped, we kept them separate. Now, when we do a dissolved buffer, what ends up happening is, rather than having it be like this, instead, right, we end up with something that looks like this. Right, you'll notice that they're no longer separated. So this is a regular buffer. Right, this is the dissolved buffer. Right, and so what a dissolved buffer would do is you'd have one buffer and one record in the attribute table. So let's take a look at what this concept would look like if we applied it to the example of the farming data. So on the left here, right, this is our example of the variable distance buffer. Right, so this is the non-dissolved, right, variable distance. Right, and this was the resulting attribute table. Right, we had 5 different buffers with 5 different areas, and we had the overlap that we talked about previously. Now, what we've managed to do here on the right-hand side, right, this sort of thicker white line here, this is the dissolved variable distance. Right, and the reason we know it's dissolved is because these overlaps have been merged together. Right, and so you'll see down here, right, the attribute table down here for the dissolved buffer, we only have the one record, right? So we had 5, let me switch to the point, right? Up here we had 5 individual buffers, 5 records in the attribute table. We had data from each individual buffer, so the type and the distance and the area. When we dissolve them together, instead what we get is we just get one record with the cumulative area. Now, the thing we have to remember here is that this cumulative area here no longer double counts the area of overlap, right? And so this cumulative area is going to be our best possible solution to how much area we can irrigate. this area right here is the best possible solution to how much area is irrigated. Right? We've accounted for having different types of machines with different output distances, and we've accounted by dissolving having the overlapping areas. Okay? So this would be the answer that I would report back to the shareholder.